Welcome to the TGR Installation Construction Package Walkthrough. In this presentation, we'll provide a detailed overview of the steps required to install the TGR flat roof system, along with practical tips and recommendations to help ensure a smooth and efficient installation process. The primary objective of this walkthrough is to ensure that your team is fully prepared and confident in performing a successful TGR installation. Our intention is to provide clear step-by-step guidance that supports both new and experienced installers. Should you have any questions following this walkthrough, we encourage you to contact us directly at TerragenProjectsTeam@terragensolar.ca or by calling our office at 1-705-435-7373, where a member of our projects team will be pleased to assist you. Additionally, we are happy to arrange an online call should further support or clarification be required. Taking a look at the construction package for a TGR project, we will go through the individual pages of this package and explain in detail the different components of the system and how to properly install them. The first page of the TGR construction package is the project overview page. The main component on this page that is of importance to your team is the overview of the whole roof layout and the system layout itself. This allows for the installation team to come back to this page for a quick reference as to where the system is being laid out on the roof. Also on the project overview page in the bottom left corner is all of the customer and project information that is required. The module type, the amount of modules, the system size, tilt angle, orientation, and row spacing is all of importance to your specific project that is being installed. Looking at the second page of the construction package, this is the generic racking detail. This is a sheet that goes into every single TGR construction package and is generic to all TGR systems. On this page, you will find a brief overview of each of the components for a TGR system. In the top left corner, you will find the torque specs for all of the hardware and clamps that are required for a TGR system. At the top of the page, there is an overview of all of the components for TGR, as well as where they should be located. In the bottom left of the page, this is an overview of the different attachments for the system. You'll be looking at base rail splices, top rail splices, and then using the top rail splices, there will be thermal brakes. On the right side of the page is a overview of the different clamps required for the system, the cross adapters, the mid clamps, and the end clamps. Taking a look at the base rail splice for a TGR system, this is an external L bracket that will be placed over two ends of base rails to connect them in a system. Each base rail will have two holes at the end of the base rail that when the base rail splice is placed over top of them both, they will get connected together using the bolts and nuts provided. The base rail splice locations are indicated on the base rail plan as black circles so that the installation team can properly install these splices in the correct location and have the base rails continuous through the system. Top rail splices for the TGR system is an internal splice. When connecting top rails together at the splice location, you will slide one end of the top rail splice into the top rail and slide the next top rail through the splice. You will butt these top rails up against the hex head in the middle of the splice to ensure that the bonding clip attached to the top rail splice is fully engaged with the top rails, as this will allow the bonding current to continue through the system in the east-west direction. Top rail splice locations are shown on the top rail plan as black circles to ensure that the installation team is properly installing the splices in the correct spots on the system. When installing modules, the usual gap between them will be 20 millimeters. This can be accounted for by using the mid clamps. At the thermal brake locations, using the top rail splice, you will keep the usual spacing in the top rails. and the space between the modules will increase from 20 millimeters to 122 millimeters. This will allow for enough room for end clamps to get installed on the top rails holding the modules down, and this gives room for any expansion in the system. Also shown on the top rail plan is the thermal break locations. These are shown as brown hexagons on the top rail plan and outlines where the thermal break expansion points need to be installed. So using the top rail splice, the gap between the modules will increase to allow for any expansion in the system. Anything that will be moving and expanding can do so through these thermal break locations. Taking a look at the different kind of clamps that are required for the system, the first kind of clamp that will be installed are the cross adapters. These are to be used by connecting them to the long leg of the triangle assembly and snapping them into place, holding down the top rails. Each triangle assembly will have 4 cross adapters connected to it, meaning there will be 2 cross adapters holding each top rail down on each triangle. You want to ensure that when installing the cross adapters that both legs of the clamp are fully engaged with the triangle. You will know that it's fully engaged because you will hear a very audible click when the clamp gets pressed down onto the triangle leg. Another way to install these is by sliding them onto the ends of the triangle and sliding them into the proper placement. Connecting to the top rails, you will have the top half of the cross adapter loose. By tightening it down, you will then put the little lip of the cross adapter into the slot and lip in the top rails. One side of the top rail will have a C-shaped slot in it, whereas the other side of the top rail will have a little lip that the cross adapter can sit in. The other 2 types of clamps that will be used to install a TGR system are the mid clamps and the end clamps. These are used to hold the modules to the system. The mid clamps will get installed on top of the top rails in between modules. So these mid clamps are what allows for that 20 millimeter gap between those modules to stay in place. The mid clamps do have a bonding washer that is installed on them. This bonding washer will need to be installed underneath the modules with the top of the clamp fastened down on top of the modules. You will always have 2 mid clamps between every 2 modules. The end clamps are installed at the end of the module arrays and in the thermal break locations. The end clamps will be at the end of the top rails on the ends of the mods where an array ends. You will need to ensure that there is at least 2 inches of top rail overhanging past the end clamp. This allows for that room for any expansion and any movement in the components of the system, and will stop the end clamps from falling off of the top rails. Again, like the cross adapters, the mid clamps and the end clamps, you need to make sure that the legs are properly engaged with the top rails, and you will hear that clicking sound when installing them. With the end clamps, you also want to make sure that the clamp is tight against the frame of the module and there's no gap between the module frame and the clamp itself. Taking a look at the next page of the construction package, this is the generic rubber and ballast detail. Again, this page is generic to all TGR project packages. On this page, we will find the rubber pad layout and the ballast layout. First, looking at the rubber pad layout, there is a generic location for the rubber pads to be installed. This can vary based on the project. On every TGR base rail, you will have the hole locations for the tilt assemblies and the hole locations for the splices. In all of these hole locations, a rubber pad will need to be installed. To install these rubber pads, there is a paper backing that covers an adhesive side to the rubber pad. Peel back this backing and stick the adhesive side of the pad to the bottom of the base rail in the splice and tilt assembly hole locations. We do provide additional rubber pads for your project. In this case, you can use these extra rubber pads to stack them if needed to keep base rail off of the roof. You can also use them to add additional pads to the base rail to keep the base rail from touching the roof surface. In addition to having the rubber pads stuck to the base rail to keep it from touching the roof surface, in the special case that a 4-block ballast tray configuration is being used on your project, since these blocks are being laid down horizontally against the base rail, there's a lot less ballast block touching the base rail, and this can cause the ballast to tilt off of the base rail and touch the roof surface. In the case that these 4-block ballast trays are being used on the project, additional rubber pads should be stuck to either side of the ballast on either side of the base rail to keep these ballast blocks from touching the roof surface. This sheet is the project specific racking detail, so this will change and vary on the project that the package is for. This sheet here has all of your project specific dimensions and measurements that are needed for properly installing base rails, top rails, and modules. Taking a look at the top view on this page here, you'll see 71 inches. This is the typical base rail spacing. So this is the base rail spacing that most of the base rails in this project are going to be spaced at, unless it is otherwise noted as a non-typical spacing. Once we get into the base rail plan, I will better explain this. You will also see 24.32 inches. That is from the first base rail to the edge of the top rail. That is your maximum base rail to top rail overhang. So that is the maximum dimension that the end of the top rail can be from that starting base rail or ending base rail. Anything more than that, the TGR team will need to be contacted so we can run the dimension through our tool and make sure that it's okay, and if not, we will need to make sure that your team has the proper amount of base rails required to install additional rails into the system to account for this overhang. On the top view again, you'll see that 2 inches that I mentioned earlier. This is from the edge of the module to the starting point of the top rail. This allows for any expansion in the system and stops the end clamps from falling off of the system. On detail A, there are quite a few different dimensions here. We give you from the bottom of the rubber pads to the bottom point of your module. We also give you from the bottom of the rubber pads to the top point of your module. The 54.44 inches noted in the middle of the detail, that is your tilt assembly hole spacing. These holes are already pre-punched in your base rails and do not need to be done on site. The one key dimension that you'll want to take away from this is the 98 millimeters or the 3.87 inches that is shown from the end of the long leg to the top rails on the tilt assembly. So this 98 millimeters is where your top rails are going to start in order to keep them square to your system. A good tip that you can do when installing your top rails on site is creating a jig to that dimension. So in this case, you'll cut a piece of wood to 98 millimeters and you can place this jig on your tilt assemblies and mark off with a paint marker where those top rails need to sit. Additionally, you can also install those cross adapters where those paint markers are, so then when top rails are getting installed, you already have those starting points with the paint marker or the cross adapters, so you know exactly where your top rails need to get installed. Another key dimension on this detail A here is the 550 millimeters or the 21.65 inches. This is the clamping zone for the module. This is specifically outlined in the module installation manual. Using that 550 millimeters allows for the module to be properly installed on the system and stay within the module warranty. The 550 is within the zone that was provided in the installation manual for this module. If at any point the installation team needs to deviate away from the clamp zone that is provided in this package, please let us know. We need to double check the module installation manual to make sure that the dimension that is being used is still within the module warranty outlined in the package. Looking at the base rail plan of this project, in the top right corner you will notice that we have the legend. So for this project there is one base rail length and there are the base rail splices. If your project is to have more than one base rail length, all of your base rails will be provided to your longest length, and the shorter base rails will need to be cut on site. This is something that will be noted in the notes of the base rail legend on the base rail plan. Also up in that top right corner at the bottom of the notes is your typical base rail spacing. So there's that 71 inches that I mentioned earlier that was in the racking detail. Looking at the base rail plan itself, you'll notice the 71 inches is noted there again with TYP written underneath, so that's your typical base rail spacing. The other two dimensions given there, the 74.96 inches and the 34 inches, those are non-typical base rail spacings. So every other base rail on this drawing here that isn't marked off is going to be that 71 inches, that typical base rail spacing. The other dimensions we have provided on here are the ones that are bordered. These bordered dimensions are starting points for your base rails. So on this project we've given the first base rail and the last base rail. The top rail plan is laid out fairly similarly to the base rail plan. You'll see in the top right the legend for the top rails being used in this project. There are 4 different top rails being used here. 3 of these lengths are supplied to length, so the 140, the 231, and the 276 inch top rails are all being supplied to length. The green rails, the 272.01 inch top rails, these are to be cut from the 276s. These green rails will always be shown in your top rail plan as your thermal brake rails. So you will always have a green rail that is cut from your longest top rail length right before your thermal brake location. After the green rails, you see those brown hexagons. Those are your thermal brake locations. So where you see a brown hexagon on your top rail plan, this is where you will increase the space between your modules from 20 millimeters to 122 millimeters. And instead of installing mid clamps between the mods, this is where you will install your end clamps. So because the space between the modules is increasing, a regular length top rail could not fit there, hence the reason to cut your longest top rail length to the length provided for the green rails and install that rail instead of a full length rail. You will also notice that we provide the 24.33 inch spacing again on this plan here. This is what I explained on the racking detail as the first base rail to the start of the top rails. Where this dimension is shown, you will also see little triangles on the ends of the top rails here. These are your starting top rails. So there is a note on this page up in the top right that says to start the installation from the side marked with a triangle. We will always put that starting dimension, so in this case the 24.33 inches, at that same location as those top rail triangles. If at any point a base rail is moved and the top rail is not the typical spacing from the base rail, this will also be noted in this top rail plan. In addition to the regular dimensions here, we also provide border dimensions on this page. This is giving you your starting and ending module to the building edge dimension. So on the base rail plan, we provide you with base rail to building edge. Here we're giving you module to building edge just to double check and ensure that the modules are getting installed in the correct location. Looking at the ballast plan of the sample package here, there are 3 different components to this page. The green squares are your solar modules. The gray lines are the base rails. These are laid out the exact way that the base rails in the base rail plan are being laid out. And then the numbers, those are the amount of ballast that need to get installed on that base rail location at that module. So looking at the numbers of blocks here, we range from 2 to 10 ballast blocks per base rail section. Down at the bottom of the sheet, you will see that there is a ballast configuration. This shows the installation team what configuration of ballast needs to be used for each of those ballast locations. You will also notice that we have noted there to CRS3 for the ballast clip reference. This is bringing you back to your racking detail for the project. Up in the top left corner, you will see that we show what each of those ballast blocks is. So the 2-block ballast, the 4-block stack, and the 4-block ballast. We also note there which of the clips that are being provided by us are being used for these ballast. I would also like to note that the racking detail shows you your max block configuration. So for the sample package, here is what 10 ballast blocks would look like underneath a triangle. This is how it would need to be installed on the project when the installation is happening on site. Thank you for taking your time to follow this TGR installation construction package walkthrough. We hope that this guide has provided you with the clarity and confidence needed to carry out a successful installation of a TGR system. Should any questions arise after viewing this walkthrough, please do not hesitate to contact us at TerraGen Projects Team at terragensolar.ca or by calling our office at 1-705-435-7373. A member of our projects team will be ready to provide you with assistance. If your team would benefit from additional guidance, we can also provide you with additional support sessions upon request. On behalf of the entire TerraGen team, thank you for your continued trust in our products and solutions, and we look forward to supporting your success with this TGR system.